All right, today I am going to go over how to solve equations using square and cube roots. The first part that you need to know about solving equations that involve square and cube roots is that you're going to want to use your inverse operations, just like we have been with solving equations to cancel something out. So for instance, like if you're trying to cancel addition in an equation, you would be using subtraction because that's its inverse operation. So if you're using subtraction, you'd want to use addition. If you're canceling multiplication, you'd use division. And if you're canceling division, you would want to use multiplication. So the same thing goes for when you're solving equations with squares and cubes. If you have a variable squared and you're trying to get it alone, to isolate that variable, you would want to square root it. So x squared, the inverse operation of squared, is a square root. And the inverse operation of cubed is a cube root. Just like in addition and subtraction, this goes both ways as well. So if you're trying to get rid of a square root, you would be squaring. So you'd want to do whatever you have squared. And then if you're trying to get rid of a cubed root, you would want to cube whatever that is. I'm just going to go ahead and put a variable here so that we have something that's represented. All right. The second thing that you need to know about solving squared and cubed equations is that you're going to want to know pretty quickly if you have a perfect square as your answer or a non-perfect square, or what something is squared, what something is cubed. So I always recommend making yourself a chart of your squares and your cubes. You will not be allowed a calculator on your upcoming test for this, so getting used to making this chart and kind of slowly memorizing these numbers can be really useful for you. So I'm going to go ahead and make my squared chart in this space up here. Right here is where I'm going to start. So I'll start with 1 squared. And then over here is going to be where I make my cubed chart, and I'm going to start with 1 cubed. You go ahead and try and make this chart go all the way through 15 on both, and then come back to the video, and you can see if your answers are correct by checking them with mine. All right, so hopefully you've paused and gone over this. So I'm just going to go ahead and zoom in and make these charts. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144, 13 squared is 169, 14 squared is 196, and 15 squared is 225. All right, now that we have our squares chart, we could make a square root chart if we wanted to. The super nice thing about squares and square roots, like I said earlier, is that they're inverse operations. So you're basically just making the same chart, starting with the opposite number and going the opposite direction. So here's what I mean by that. So I'm going to start with a 1 because that was my answer to 1 squared. And so the square root of 1 would end up being 1. Let me give another example. The square root of 4, well, that's going to be 2. The square root of 9 is 3. So you can kind of tell my answers previously. When I square root those answers, I get what I originally squared. Okay, let's keep going. So the square root of 16 is 4. The square root of 25 is 5. The square root of 36 is 6. Square root of 49 is 7. Square root of 64 is 8. The square root of 81 is 9. Square root of 100 is 10. Square root of 121 is 11. Square root of 144 is 12. Square root of 169 is 13. Square root of 196 is 14. And the square root of 225 is 15. All right, let's go ahead and super quickly make our cubes chart to help us out. Okay, 1 cubed is still 1. 2 cubed is 16. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. 6 cubed is 216. 7 cubed is 343. 8 cubed is 512. 9 cubed is 729. 10 cubed is 1,000. 11 cubed is 1,331. And 12 cubed is 1,728. I'm not going to go as high on our cubed chart just because you can see that they grow much faster than our squares, so we most likely won't need something past 12 cubed. If you'd like to keep going, you can. And then the same thing happens for your cubed root. Your original answer previously is now what you're putting under that cubed root, and your answer is going to be what you were originally cubing. So the same relationship exists between a cube and a cube root that existed between our square and our square root. So I'm going to go ahead and just fill out this chart. All right, now that we have those tools available to us in those charts, super easy to see, let's go ahead and start solving these equations. So let's say we have x squared equals 64. It might be super easy, you might have it memorized. So you can always look at your chart, or if you have it memorized, you kind of probably know, okay, well 8 times 8 is going to be 64, so I know that x should equal 8. But the way that you would want to solve this using our equation rules is what I'm going to say that we've used in the past, is by canceling that squared to get x alone. The way you would show this in an equation is square rooting both sides. And when you square root both sides, that square root cancels that squared. So you would have x equals, and then whatever the square root of 64 is. This is when you would want to go ahead and look at your chart and say, okay, square root of 64 is right here. So that means that my answer has to be 8. All right, let's go ahead and do another one. Let's say that you had x cubed equals 64. So the difference here is that instead of using my square root operation, I would want to cube root this because I'm trying to cancel a cubed. So on both sides of this equation, I would want to cube root in order to cancel out that cubed. That way my x is alone on the left, and I can solve that on the right to get my answer for x. So now that I have that x is equal to the cubed root of 64, I'd want to make sure I'm going to my cubed root chart, not my square root chart, and seeing, oh, okay, well, the cubed root is 64. That's 4. So I'm going to go ahead and go back and say x is equal to 4. All right, let's go ahead and solve the equation below. So now we have x squared minus 8 equals 136. This is super similar to the equations we just solved, except for now that you can tell there's another term involved. So we have our x squared term, our negative 8 term, and our 136. And so we're wanting to get that x squared alone, which means we need to first cancel out that minus 8. And so I will add 8 to both sides, or use the addition property of equality in order to cancel that. So now I have just x squared is equal to 144, because that's 136 plus 8. And now I would say, okay, well, my x squared is alone on one side, so I can go ahead and use my square root operation to cancel that squared. And so I know I would have x equals, and then the square root of 144. Now this is when I would go ahead and go back and look at my chart and say, okay, where is the square root of 144? Well, the square root of 144 is right there, so I can very clearly see that that's equal to 12, so I can go ahead and say x is equal to 12. All right, let's solve our cubed equation. So in this one, we have x cubed plus 7 is equal to 132, and again, that plus 7 term is in our way of isolating our x cubed, which is in the way of isolating our variable x. And so we're going to go ahead and want to cancel that positive 7. So we're going to go ahead and subtract 7 from both sides, or use the subtraction property of equality to cancel that. So then we would have just x cubed is equal to 125. Well, now my x cubed is alone, so in order to cancel out that cubed, I'm going to go ahead and cube root both sides, because that's the inverse operation of cubed, so that cancels. So now I just have x equals, and I need to go ahead and go back to my chart here and find where I see the cubed root of 125. So I'm going to my cube chart on the right, and there it is, 125. So I can see right there that the answer to this equation is going to be 5. Just like previous equations, you can always check your answer by plugging in what your answer is and seeing if you actually correctly solved for the variable. So let's go ahead and do that on the left equation. So let's double check our answer of 12 here. So if I double check it up here, I would say, well, 12 squared minus 8 should equal 136. Well, if I look at my chart at the top, 12 squared is 144 minus 8 should equal 136. Well, 144 minus 8 is indeed 136, which is what we wanted, because that means that 136 is equal to 136. So we can go ahead and check that off. Let's go ahead and check this cubed one as well. So in this case, we'd be looking for 5 cubed plus 7 to be equal to 132. Well, looking at our cubed chart, 5 cubed is 125. So we would have 125 plus 7 is equal to 132. Well, 132 is indeed equal to 132, so that's correct. So now we know that we've properly solved these cube and squared equations. I hope this helped you out with your asynchronous this week, and enjoy the rest of your day.